Hello, my name is Michael Jones, and I am the founder and director of the Pacific Rim Headache Center here in Anacortes, Washington. And I have worked in headache disorders for 31 years, starting my career with Joel Saper at the Michigan Headache, what's now called the Michigan Head Pain and Neurological Institute in Ann Arbor, Michigan. After that time, I worked for a number of years at Mayo Clinic's Department of Headache before coming out here to Western Washington, and have been here for a little over 10 years. Now, in my years of working in headache, I've seen a lot of changes that happen in our understanding of what headaches are and how they're treated. In the early days, in 1982, when I first got started working in headaches, we had a lot of information that we would pass on to patients, and looking back, that was really based on mythology more than anything else. Over these years, I've been going to the American Headache Society and the International Headache Society scientific meetings, and I've seen this evolution of knowledge into what causes headaches and how they're treated. But there's this great disconnection between what we now know to be factual and what is known, I guess you would say, on the street, or in the layman's terms, or sometimes even medical providers, what they're saying about headaches, what causes them, and how to treat them. But today I just want to talk a little bit about the underlying cause of most headache syndromes. We don't know the whole story, and who knows what percentage we know, but it's at least 20–25% of the whole story, which is a lot better than what we used to know. And what I'm going to do, I'm picking out, there's about 135 different headache types, and some of them are totally different than others, but the vast majority of headache disorders fall under a category of the migraine family. Now, we used to think that the majority fell under what we call tension headache, but that wasn't, that was part of that mythology, that we believed that those headaches were caused by stress and tight muscles. But then research started to show that that wasn't true, that there was not tight muscles involved, and it didn't seem to correlate that well with stress. Now we're starting to think that most even daily headaches are caused by a migraine phenomenon that we now call chronic migraine. So I'm going to be talking about the most common types of headache and the underlying cause to them, and not really so much about treatment, but just what we call the pathophysiology of headache. And this makes up probably 80 or 90% of the kind of headaches that we see in headache clinics. Now, migraine is divided into two subtypes of migraine with aura. That means migraine with some type of neurological event, usually vision aura, and migraine without aura, that just simply the headache itself. And there is some disagreement about how those two types of headaches connect to each other, but I'm going to try to tell a story that explains both types. And I'm going to start with the most common type of migraine, which is migraine without aura. And the way that we look at it is this. In research, we have found that the way the brain is structured, that there is an area down deep in the brain stem. Now, you have to remember that the brain itself doesn't perceive pain, so we're not talking about the location of where you perceive pain. But down deep in the brain stem is an area that goes by the geographical name of para-aqueductal gray. So if you imagine hundreds of years ago when they first started dissecting human bodies, and they would just name things what they looked like. In this area, this was a little tube, if you can see it, is just the aqueduct or water pipe. It is really a pipe for spinal fluid to flow through the brain. And in a real brain, this area around that water pipe in this particular area is gray in color. So that's where that name para-aqueductal gray comes from, or PAG. And we think in some ways that is the root to headache pain in a way that it's a control center, and its job is to make headaches. Now, wired into this area it's sort of a crossroads to major nerves that come outside the head. The nerves in the front called the trigeminal nerve. Tri means three, Gemini means twins. When they first dissected this nerve in the front of the head, they called it the three-headed twin, so the trigeminal nerve. There's one on each side that divides the head in three major groups. Also wired in through the brainstem or two big nerves that come out the back of the head called the occipital nerve on each side, and even some of the high cervical nerves are connected into this alarm system in the base of the brain. Now, here's a way I explain why we have this, and you can see it from an evolutionary way, or you can just see why it makes sense that we would have this, or why we would be designed with it. And imagine if you went back a few thousand years ago and someone was out in the jungle and that person started developing meningitis. Well, meningitis can be bacterial or viral. Let's say it's a viral meningitis. So there's this virus growing inside the skull around the lining of the brain. And believe it or not, the virus itself probably doesn't cause a lot of problems at first. So if it was just the virus, you probably wouldn't even know it. But this alarm system has sensors throughout the whole head and the brain. And when it senses that something is not right, it will then turn on and start to send signals down these big nerves that come out to the front or to the back or even down into the neck. And the nerve endings themselves act like the sprinklers in a building that's on fire. They open up and spray water. Well, these nerve endings open up and release 4 known chemicals that are, it's like a soup of inflammation and irritation. Now, some of this happens inside the skull, along the lining of the brain called the dura mater, or tough mother. It's a tough membrane that's loaded with sensory nerves. And some of it happens on the outside of the head. Now, this alarm system then, if we go back to our story of the caveman or someone thousands of years ago getting meningitis, well, the alarm system perceives the virus, it turns on, it sends signals down these nerve endings, to these nerve endings. They open up, release the chemicals, and those chemicals cause pain. Now, the pain from the headache would make the person stop hunting the bison, put down their spear, their bow and arrow. They'd go to their little hut. They don't want to be around other people. They don't want to be out in the sun because of the light. The food in their stomach is regurgitated, and they go to bed and lay there. And that was probably the very best thing that they could have done for meningitis to survive. Lay in bed, don't eat, let the body fight the infection and get better. So that's why we have that alarm system as a protective way to protect our bodies, our head, from problems. And the alarm system will go off in other situations too. Brain tumors, strokes, even the flu can cause the alarm system to go off. Well, in the case of migraine, especially migraine without aura, we're not sure what the culprit is, but we think that genetics play a very big role into this. And it's probably some subtle defect in this alarm system that makes it turn on very, very easily, just like a car out in the middle of the mall parking lot whose alarm system goes off just when the wind blows a little bit. So the alarm system in the car is designed to go off when a bad guy is breaking in the car, but it starts to go off for no serious reason, just because the wind is blowing. So the migraine sufferers, and in most of the countries they've studied, about 18% of women have migraine and a little bit less for men. We think those people have a genetic predisposition due to a defect in this alarm system that makes it come on spontaneously. Now, within those people with migraine, there's a spectrum. On the good end, and I happen to be on the good end, fortunately, is because my mother had migraine, my sister has migraine, that those people are very susceptible to triggers. I have a very strong trigger for me, and that's sleep deprivation. If I stay up to 3 or 4 in the morning, then go to bed, sleep a couple hours, and then get up, and I've had to do that many times, I will almost invariably get a migraine before the day's over. Another good example are women who have menstrual migraine. So there's nothing wrong with their estrogen or their hormones, but this natural cycling of estrogen is all it takes to set off this defective alarm system. It turns on, it sends signals down these nerves. The nerves open up and release the chemicals that cause a bad headache. Now, the term migraine itself is from a Latin word hemicrane, which means half of the head, and that word got translated to hemicrane, migraine, and migraine. Because often that little alarm system would pick one side, it will send the signals up, and where the chemicals are dumped to cause the pain. A lot of other patients, it goes up both sides equally, and some patients will switch from one side to the other. Now, on that spectrum I was talking about, if you come down that spectrum, you'll find people who are more and more susceptible to different triggers. The biggest ones that we know of are sleep deprivation, menstrual cycle, dehydration, missing meals, and then we get to specifics such as foods. Now you could buy 100 books out there that tell you these diets that supposedly cause migraine, but they have very little scientific evidence behind that. So we have to be very careful, and when we tell patients that if you follow this strict diet, your headaches will get better, because there's really no scientific proof for that, even for chocolate, red wine, and those things. In the last few years, there's been some studies even to contradict that, saying that cocoa might even help headaches. And there's studies showing that red wine may not make headaches worse. But each individual has to decide for them if whether or not triggers such as certain foods or what can bring on a headache for them. Now, anytime you have a disease state or anything in life that's paroxysmal, that comes and goes, it's very vulnerable to developing superstitions about that. And the best example are people who design one-armed bandit slot machines. They know that they randomly give a reward. It makes people superstitious that they pull the handle a certain way, they'll get the reward. So sometimes that happens in migraine, that patients will have a horrible migraine. And I know I've been guilty of that myself. And I start thinking back, what did I do the day before? What did I eat? Oh, I ate, potatoes. So I'm not going to eat potatoes anymore. So there's some superstition there. But each patient has to decide for themselves if there's triggers. Now, as you come down that list, or that spectrum, you get to the very bad end of the disease state. And most of these patients have no triggers. This alarm system comes on randomly, or it comes on and stays on all the time, and these patients have headaches every day. And it's not due to any type of trigger that they're exposed to. So I hope that makes sense of what causes migraine. It's a defective alarm system in the brain, most times genetic, can be brought on by trauma. I've seen it come on after things like meningitis, surgery, and brain surgery for tumors, that then they develop these type of headache syndromes. But most of the time we think that genetics play a big role. Now, most things in diseases are what we call nature and nurture. Nature, of course, being genetics, and nurture being things that happen in life. And there can be a combination in migraine. I've seen identical twins where one will have a few migraines and the other one is devastated with migraines every day. So there's something that happened in their lives that made one more vulnerable to the other. So there is that influence, but genetics really play the biggest role in that type of migraine. So this is where we think most common headaches come from, what I just described. The things that there is absolutely no scientific evidence to support are these common headaches are caused by sinus, not true, not caused by allergies, not caused by any kind of bone been out of alignment, not caused by jaw been out of alignment, not caused by dental work, not caused by mercury fillings, not caused by electromagnetic waves. I could go on and on, black mold, all these things you'll read about on the internet. You'll have people, even medical professionals, claiming that these cause headaches, but there's absolutely no scientific facts behind that. Just like with weight loss, fad diets, there's tons of those you can read about, but very few have any supporting evidence for it. So I work in evidence-based medicine, and the only things we can say confidently are those things that we know for sure. So what I just described are things that we know for sure. Now I'm going to move on and talk a little bit about migraine with aura. For us in evidence-based medicine, or medicine in general, these are some of the most fascinating headaches and actually have been studied the most. So I'm going to start a little bit different description for that. Now, it could be true that both headache types have the same root, and I'll explain that in a minute. But migraine with aura is a migraine that, if you follow the textbook, starts with a neurological change. Most of the time vision, sometimes numbness, tingling. Less often it can be things of motor weakness. And there's a type of migraine called basilar migraine that can even cause confusion, disorientation, trouble speaking, and even loss of consciousness. But those are rare. I have 1 or 2 patients a year at the most with that disorder. Now, the way the brain is set up, this one is color-coded. The brain, of course, is not this color at all. Even the gray matter is not that color gray. But the back part of the brain is where we process vision. In this model, the green area is where we process sensitivity, touch. The pink areas where we process motor movement, and in the yellow areas where we process language. Now, the way the human brain or any animal brain is set up is that the neurons on the surface of the brain behave like electrical capacitors. Now, I know that people in this day don't know what that is unless you're an electrical engineer, but when I was a kid, we probably knew more about capacitors because they were far more common in life. But one good example of electrical capacitor are these old disposable flash cameras. You would turn on the flash and you'd hear this noise as the capacitor charges up with a very high voltage to fuel this very bright flash. So this is the way the neurons are. They're in a high state of energy. They're all charged up, ready to be used and to function. Now, the way the brain is, if you traumatize the brain, even with minor trauma, such as poking the brain with a needle, dripping a little potassium on the brain, you will start an electrical disturbance. And this electrical disturbance behaves like throwing a pebble into a pond and there's a ring moving across the pond. Now, the reason it behaves that way is the very center of that bullseye, where the neurons are traumatized, they will misfire. But when they misfire, they release a chemical, glutamate, which then plugs into the surrounding neurons and it causes them to destabilize and misfire. They then release the chemical, which causes their surrounding neighbors to destabilize and misfire. So in that way, you get a concentric rings moving out slowly across the brain. And it's been measured about 3 millimeters a minute. This will spread across the brain. Now, on the cutting edge of this electrical disturbance, the neurons are firing. And that might be responsible for flashes of light that some people see. But then behind that firing, the neurons have to start recharging back up. And it's during that recharging you actually start to lose areas of vision, black spots or blank spots. Now, most of the time, this visual disturbance will stay in the back of the brain, but if it spreads up into the green area on this model, then you can start to get numbness, tingling in face, hand, leg, usually one-sided, or move into the motor area, which is even far more rare, where we actually have paralysis. Now, in this condition, we know more probably than how I describe common migraine because we think we know what's the underlying cause for most patients. There's 4 genes that I know of that can be responsible, and they're all very similar. And they seem to affect the way these neurons charge up. And these genes I've talked about are genes that make you prone to migraine with aura. Now, these neurons are very complicated. And one of the processes it uses to maintain the proper voltage gradient across the membrane of the neuron is allowing calcium to come into the neuron. And these are called low calcium channels. So one of the genes, or some of the genes that are involved in migraine with aura are disorders of this low calcium channel. So there's a disproportion of calcium going into the interior than what should be there, causing the voltage gradient to change, and that makes that neuron more vulnerable to misfiring. So in migraine with aura, there could be some stimulus, like for women going through a menstrual cycle, a stressful day, a weather change, something, or most of the time it's something internal in the brain that we can't even measure, will tip the scale and cause this neuron to fire. It starts the ring moving across the brain, the vision disturbance happens, and then if you follow the textbook style of migraine with aura, then the old alarm system that we talked about down in here gets involved. So the electrical disturbance does not cause pain, but the alarm system down here will cause pain. It perceives that there's been electrical disturbance and it's doing what it's supposed to do. It's warning you that something just happened. It starts sending signals out these nerves and they release the chemicals causing pain. And then as this alarm system can gear up, it'll start to send signals up into the brain to make other changes. Now, the brain is extremely complicated. I used to describe the brain as a supercomputer, but it's far more complicated than that. I think the better picture is imagine a big football stadium packed with about 1 billion laptops all wired together in a convoluted array of wiring. So it's very complicated. But one of the way the brain works is it has a damper on our senses. So if you take that damper away through this complicated circuitry, then the senses become more acute and more aware. Light becomes brighter, sounds become louder, food, which start out being tasteful, becomes distasteful and nauseous, and then even vomiting. And that's how all these symptoms occur when you have migraine. Now, that was the main thing I want to talk about with the actual cause of migraine. And the things I've said are true. It's not my ideas, it's not something I made up, it's not some mythology. This comes from the hard work of really brilliant scientists, MDs, PhDs, who spent their whole careers working on this problem of migraine. I think of Michael Moskowitz at Harvard and his team, and there's several other teams around the world who've worked very hard in figuring out migraines. So it's hard for me when I see patients coming in and they've read on the internet about electromagnetic waves of power lines or cell phones or black mold or spine valve alignment, or now the big thing is jaw valve alignment, which has no research to support that as the cause of these kind of headaches. Now for treatment, and this is a whole nother topic I'll have to get into, involves, I describe to patients 4 major ways to help prevent headaches from coming. One way is simply looking for triggers and trying to prevent them. That's the way I control my migraines, because I'm on that good end of the spectrum. I try to make sure I get good sleep when I can. Sometimes I can't. But some people have no triggers, and they need to accept that and stop spending their entire lives trying to find some secret trigger that's causing their headaches when there are none. It's this complicated genetic problem. The second thing is what I lump under the hands-on things. So there's treatments that involve touch, and I'm talking about massage and acupuncture, and some people say the chiropractic helps them. And there's a few patients who have had injuries in their neck that can act as a trigger for a migraine that comes up here. So by dealing with the problems in the neck through blocking nerves or other things, it can help the headaches. The third thing, there are some nutritional supplements that seem to be modestly helpful in preventing headaches from coming. Now, people who don't work in Western medicine will make the claim that we're not interested in natural supplements. We're very interested in natural supplements. I would wish more than anything there was some plant product that you could take that would stop your headaches from coming, something natural, cheap, and safe. But unfortunately, for me to say that, I'd be lying, because it's not true. There's been many studies on non-drug ways to prevent headaches using natural supplements, and the vast majority have shown no benefit. And I think one is feverfew, which the health food stores push. The only 4 that we know of at this date, and in the future there might be other ones. There's an herb called butterbur that's done some good studies, placebo control. There's just a few scant studies with riboflavin, coenzyme Q10, and magnesium. And then the last thing are medications. And I'm just going to mention those for a moment. There's 3 categories of medications: those that prevent headaches from coming, those that turn off the alarm system, and then the last step are rescue medicines that simply numb up your head so you don't feel the pain. And that's really our last resort. We are really interested in treating the root of the problem. And the root of the problem is this genetic disorder in the brainstem, or out in the cortex of the brain in the case of migraine with aura. There's no way to cure that right now. Simply people can outgrow it, and I hope that happens. But right now there's no cure. Someday there will be a cure, and I really believe that, but it may not be in my lifetime. It's going to be through genetic or gene therapy, putting in the correct genes. But in the meantime, we use medications that compensate for inborn errors of the brain. We don't know how all the medicines work. They don't cover up headache. Headaches do not occur when they work right. So there's at least 25 to 30 preventative medicines that's been discovered over the years. And for most people, they'll find one medicine that's quite effective in preventing their headaches from coming. There's no moral problem in taking a medicine to prevent your headaches. Most medicines in the U.S. are very safe. The FDA follows very strict protocols that letting medicines only come to the market that are safe. The risk of medicines that do have potential bad side effects are extremely remote. Driving to your provider's office is more dangerous than almost any medicine you can imagine taking. So it's unfortunate that they get a bad reputation. Part of the reason they get a bad reputation is that for legal reasons, they have to list every remote possible side effect you could have. Otherwise, they could be sued and lose millions of dollars. So it gives us false impression that these medications are dangerous things, that patients shouldn't be taken. If they do take it, they have some kind of moral problem, but that is not true. So the last thing I was just talking about are medications for prevention. Then there's medications that actually go to the root of the problem and turn off the headaches, and those are what we call triptans. And then the last resort are pain medications. Pain medications have to be used very cautiously, because if they're used too often, they will actually make this brainstem alarm system more prone to misfire and cause more headaches. And our goal is for patients to be well and happy.